Sometimes when we need to correct not the whole image but some of its fragments, we should use methods which apply to some areas of the scan. So I call this set of methods Aftertouch. First method, like the most simplest one, is named crop. In case when you get some nice image, but at some area of your scan from the side you get some piece of dust or something that doesn't concern your result, we just cut it off, and you can use crop method where you can set the exact sizes of the crop rectangular and exact position. And from the right side you see the result, so we see our nice object without the dust from the left side. Another method is called cut peaks, because sometimes in plane everything's wonderful, but some big features, like in this example, they take most of color from the color palette, and finally, and so you see the dark background with some bright particle which doesn't have any scientific meaning. And in this case, we can just cut pixels which lay out of area of our interests. To cut the heights which we are not interested in. And cutting these pixels, we just cut this data from the image. And if you look in 3D, from the left side you see this big spike which took most of our coloration palette. And but after applying cut peaks method, we cut all these big bright points, and finally can see the object of our interest. Another very common artifact in atomic force microscopy is so-called line spikes. So in this image you see a pretty nice image of the scratch, but we can see two line spikes which could happen due to different reasons. But now our aim is to eliminate them. So you can use line filling method, which is staying in section editing of image analysis. And from the left side we have the original scan and the moving window, which we can position to our line spike using line position input box. Here from the bottom you can see the zoom of this window, and when you see the spike you will see it. And when we come to this line spike, the algorithm just removes this line by the neighborhoods. And applying this, you can press Ctrl Enter or press this button, and this line will be remembered, and go to the next line and remove it. So finally you get two lines removed and a clear, nice image. But sometimes there are too many lines which should be removed from the image, and you can see it in this example, and it might take plenty of time to do the manual removal. So in this case, editing scratches method can be used. So here on this example you see from the left side the input image with many line artifacts, and from the right side you see the mask where the method detects these bad lines. And if you look at output image, you can see that all these lines are removed automatically. One more way of removing some specific artifacts is called field by superposition, where we have the artifact we want to remove, and when we choose it, the algorithm takes the surrounding data and just removes this annoying object. Some people say that this is not honest. You should not use this method because this is not real. It's like Photoshop. But my concern is that in case you no, you should think when you do this method, when you apply any method. In case when you apply this method and you change the scientific result, in this case, of course, you should not use it. But for example, you got some nice structure and you want to represent it to your colleagues, to society, and by chance you got some piece of dust on this structure, which doesn't doesn't concern this result. So why not to remove it? Because because finally you don't change the scientific data, you just change the way of representation. But anyway, you can use it or use another methods.